Assalamualaikum students. Today we are going to start the second section of unit 3, which is related to logarithm. Logarithms are useful tools for accurate and rapid computations. There are two types of logarithms. One, common logarithms, and second, natural logarithms. The logarithms with base 10 are known as common logarithms, and the logarithms with base e are known as natural logarithms. Definition: if a raised to power x is equal to y, then x is called the logarithm of y to the base a and is written as log of y to the base a is equal to x, where a is greater than 0 and not equal to 1 and y is greater than 0. Here we have two relations and these two relations are equivalent. A raised to power x is equal to y or log of y to the base a is equal to x. So we can write as these relations: a raised to power x is equal to y if and only if log of y to the base a is equal to x. Deductions from definition of logarithm. First deduction is that since we know that a raised to power 0 is equal to 1, by using this is the exponential form. Now this form can be converted into this form. So log of base a of 1 is equal to 0. So by using this logarithmic form, a raised to power 0 is equal to 1 can be written as log of 1 to the base a is equal to 0. So we can say that log of 1 is always 0. Log of 1 to the base 10 is equal to 0. Log of 1 to the base e is equal to 0. Log of 1 to the base 2 is equal to 0. Second deduction. Since a raised to power 1 is equal to a, and using this relation, log of a to the base a is equal to 1. So this deduction says that if we have log of 10 to the base 10 is equal to 1, log of 2 to the base 2 is equal to 1, log of e to the base e is equal to 1. So these two are very important deductions. So let's move toward exercise 3.2. Question number 4. What replacement for the unknown is in each of the following will make the statement true? Part 1. Log of 81 to the base 3 is equal to L. Just we have to find the value of L. Solution: log of 81 to the base 3 is equal to L, and by using this relation, so this is by converting into the exponential form, 3 raised to power L is equal to 81, and this 81 can be written as 3 raised to power 4. So by equating these exponents, L is equal to 4, that is required number. Second part, log of 6 to the base a is equal to 0.5. Solution: log of 6 to the base a is equal to 0.5. In the exponential form, this can be written as a raised to power 0.5 is equal to 6. So 0.5 mean we can write this as a half is equal to 6. Now by taking square on both sides, in the next step we have to take square on both sides. When we take square on both sides, this cancel out with this and we have left with a is equal to 36. Question 5. Evaluate log of 1 over 128 to the base 2. Let this is equal to x, and by using exponential form, 2 raised to power x is equal to 1 by 128, and 128 can be written as 2 raised to power 7. So this can be written as 2 raised to power minus 7 by equating these coefficient x is equal to minus 7. Part 2. Evaluate log of 512 to the base 2 square root of 2. So let x is equal to log of 512 over to the base 2 square root of 2. By using exponential form, this can be written as 2 square root of 2 raised to power x is equal to 512. Now this 2 into square root of 2. 2 square root of 2 mean 2 raised to power 1 by 2. And 2 simple mean 2 raised to power 1. Since these two values are multiplying and bases are equal, so we can add these exponents or powers. So this can be written as 2, 2 ones are 2 plus 1, and this is equal to 2, 3 raised by 2. So we can write 2 square root of 2 as 2 raised to power 3 by 2, and this is x. Now this x multiply with this by equating these exponents. 3 by 2 x is equal to 9. Now we have to just multiply 2 with 9. We have 3x is equal to 18. Now dividing both sides with 3, we have x is equal to 6. So this is the question number 5. Now question number 6. Find the value of x from the following statements. Log of x to the base 2 is equal to 5. Solution. This can be written as in exponential form. 2 raised to power 5. 2 raised to power 5 is equal to x. Or x is equal to 2 raised to power 5. And 2 raised to power 5 mean 32. 2 multiply 2 raised to power 5 mean 2, 2, 2, 2. And this is equal to 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. So x is equal to 32. Log of part 3, log of 8 to the base 64 is equal to x by 2. So now using exponential form, 64 to the power x by 2 is equal to 8, and 64 can be written as 8 square. This 2 cancel out with this 2, and we have left with 8x is equal to 8. So 8 can be written as 8 raised to power 1. So by equating the exponents, x is equal to 1. So this is the second lecture, and I hope that you can solve the remaining parts of question 4, 5 and 6. So Allah Hafiz.